We're back. It's so great to be back in person. So this morning you've heard a ton about scale, and not to disappoint, I am going to tell you a bit more about scale, but I'm also going to have a little bit of a twist, and that is to tell you a little bit about how to be responsible when thinking about scale, and some of the work that we've done at Meta AI in order to be responsible as we're scaling and innovating. Okay. So the plan for today is I'm going to tell you a little bit about how some of the important problems that we need to solve leveraging AI here at Meta. And then I'm going to go through a lot of the scaling trends that we've seen, not only within Meta, but throughout the entire industry. And then finally, I want to wrap it up by talking a little bit about what we're calling green AI. And this is thinking about how to be responsible, what are all the opportunities for really innovating, not just when it comes to scaling, but also innovating in terms of efficiency and leveraging resources well. Okay? So it probably won't be a big surprise to most people here that Meta relies a whole lot on AI and has a lot of really hard problems that need to be solved in order to leverage scale and to innovate. So there are things like we need to be able to keep content safe, we need to support many different languages and modalities, we have to do ranking and recommendation for ads and newsfeed, and looking forward, we have a gazillion problems to solve in terms of the metaverse. Okay? Some of the wins that we've seen recently when leveraging large-scale models are things like keeping content safe on our websites, where we have seen a pretty significant reduction in the amount of hateful content that gets viewed by users. We also have about half of our users whose native language is not English, therefore we have to do a lot of translation on the fly. And so at the end of the day, we end up doing about 7 billion translations across our products. And then finally, one of the most recent breakthroughs that we've had is the No Language Left Behind project, which was just released in July, just last month. And it is our ability to be able to translate now 200 languages, many of which we don't have a ton of data to train on, but we were able to do translation for them nonetheless. Okay, so next I'd like to talk a bit about scaling trends that we've seen, not just within Meta, but across the industry. And I'm going to talk about them from the vantage point of how much data has grown over time, how big the models are growing, how much training we're doing, how much inference we're seeing, and then how much compute is needed to underlie all of that training that we're seeing. Okay, so let's talk a little bit about data, right? We're already up at the petabyte scale, so we have tens of petabytes of data ingested daily. We have hundreds of petabytes of data replicated daily. We have millions of machines to be able to process all of that data that is coming in. So things are big. And not only are they big, they're growing. So this is a look at some of the data that is driving some of the models we have in production, where you can see that that data has grown over 2x in just the past 2 years. And the ingestion bandwidth as well has grown 4x over that same 2-year period. So big and still growing. Across the industry, it's probably no surprise that models are growing. If you look at the past 4 years, here's some data from Hugging Face, where we see we've gone from about 100 million parameters all the way up to now we're approaching trillions of parameters for our models. So what has this meant for us within Meta? Well, it's meant that we've seen growth across the board when it comes to training that needs to happen all day, every day. So we have, in an 18-month span, we doubled the number of engineers whose job it was to do training all day, every day. They were training 5x more workflows over that duration, and we were using 8x more compute over the same duration. Okay, and what capacity have we needed to provide to be able to do all of that compute? Well, that has grown 3x for training in Meta's production systems, and inference capacities have grown 2.5 times in that same duration. Okay, and then one of the big proud moments that we had within FAIR is that just in December, January of this year, we released the AI Research Supercluster. This is one of the world's fastest supercomputers, It has 5 exaflops of compute, a half exabyte of storage, and this is for the use of the researchers in FAIR. Okay. So next, I want to talk a little bit about what that has meant and how are we thinking about doing that responsibly. You've probably seen that many companies have defined their corporate climate pledges. All of the large hyperscalers have talked about reaching carbon neutrality or net zero by 2030. Many countries are setting climate goals as well, right? There's some things to know about some of these corporate climate pledges and the fact that it's not just a problem that's going to get solved for us and that all of us here have a little bit of a responsibility. So first of all, it's important to understand the terminology that's being used. It might seem logical that when people talk about being net zero, that they mean that all of the electrons going into the data center and running all of your models are using renewables, but that's not actually the case. It's more of offsets that are being purchased to offset the energy that is being used for compute. So that's important to understand, that it's not just direct use of renewables. We are leveraging renewables quite a bit. This figure shows the US and where all of our data centers are located, and then all of the investments that we have in renewable energy that are nearby. But it's important to know that given all of the numbers that I just showed you about growth, that it's not going to be able to keep up. We're not even caught up yet with the energy consumption of the US. It's only about 20% of the energy that's used in the US comes from renewables. So it's not going to, this problem is not going to go away on its own. So we started to think about, well, how does this impact us and what can we do about it? Okay, and the real turning point for me was in 2019 when I read a tweet by Emma Struble where she talked about all of the excitement around training large language models, but then being worried about the carbon emissions that were resulting from that. And she presented some data that talked about those carbon emissions, where you can see, just for perspective, what were the carbon emissions for an average car lifetime. And then you can see that training a large transformer model, including that neural architecture search, was producing 3 times as much carbon emissions as an entire car lifetime, right? Since that time, it's gotten worse. Now we are seeing about 5 car lifetimes worth of carbon emissions that are resulting from training some of the large models. And of course, this really hits home when you take a look back at the data that then links carbon emissions to human death. So, we don't want to cause world harm here. So we started to think about what can we do from the AI standpoint to be able to do our part. And so we came up with a pretty simple plan, and this was our Green AI plan. The first step was that we wanted to make sure that carbon was seen as a first-class citizen and a metric that you want to optimize for, right on par with cost, right on par with power. At Meta, this was a pretty straightforward transition because we already treated power as a first-class citizen. That tended to be our most limited resource. And going from power to carbon is relatively straightforward. The next thing that we wanted to do was instrument all of our systems so that we can have the right accounting of exactly how much carbon emissions is happening from everything that we are doing. And so getting that into our production systems, building tools so that people can understand the trade-offs of training one way or training a different way, or using one model versus a different model. And then we focused a lot on doing end-to-end optimization. So really thinking all the way through, from data, through training, through inference, and full stack. How can we make sure that what we have is the most efficient way that we can provide the breakthrough that we want to be able to provide? Okay, so I'll go through a few of the things that we've done in the meantime. So we've invested in tools. Internally, we added instrumentation to all of our training workflows to be able to report back to the user exactly how much carbon was used or was emitted from doing the work that they did. So lots of progress internally. Externally, we released and open sourced a tool called Carbon Explorer that lets anybody understand the trade-offs between some of the design decisions that they might be making. Then we took a look at doing some accounting on some of the models that we had in production, exactly how much, how much carbon emissions were coming from some of the top workflows that we had, and kind of broke it down. So you can see here in green, you can see for a given model exactly how much we were able to offset with renewable energy. In red, you see what we weren't able to offset with renewable energy. And in gray, you see what we actually inherited because of the manufacturing process. So before we even started training, we purchased some machines, and those machines in their production and in their manufacturing had some carbon emissions that we then inherit by, generated the demand for those compute resources. So that's important to understand, is that it's not just how we execute, but everything from how we're purchasing, who we're purchasing from, and what kind of process or what kind of practices they have in place that we need to keep an eye on. We also dug in and did some pretty significant optimizations on how can we just take a given model and optimize and make it much, much more efficient. Here's an example where we were ultimately able to get an 810x reduction in the amount of carbon emissions by looking at the entire stack, right? Looking at how are we processing the data, what compute layer are we executing on top of, what kind of optimizations, and can we just pick a better, smarter transformer to be able to make the entire system much more efficient. In fact, if you look back historically, there's a ton of opportunity. If you look at how much more efficient systems and models have gotten over the past 5 years, you see that the infrastructure advances have resulted in 11x improvement in the efficiency of the end-to-end system, but the algorithmic improvements have resulted in a 44x, so 4x more opportunity to just make the model more efficient and not just assume that the infrastructure is going to take care of this for you and that it's an infrastructure problem. It's a model problem. It's an AI problem. And in fact, there's a lot more opportunity to solve the problem at the model level. Okay, so we want to innovate, but we also want to be responsible. So can we have it all? The answer is yes. We can and should still be innovating. We just have to do it in a slightly smarter way. And so here's a good example with the No Language Left Behind model that we just released last month. We not only released the model for everyone to use, but we also disclosed exactly what the carbon footprint of the development and all of the different optimizations that we put in place. Okay, so if you take anything away from this talk, it's that it is absolutely 100% possible to do scaling in a very responsible way. It's just go ahead with your breakthroughs. Make sure you enable those breakthroughs that you can enable with scale. Just make sure that you're keeping track and measuring and understanding what are the efficiency and power and carbon emission implications of all of the different design decisions. And then optimize the whole thing holistically, and it's a win-win. Okay, so with that, thank you very much. I want to give a shout out to all of the great people on the Green AI team who contributed all of the data and results that I presented today. Okay, thank you so much.